Okay, let's continue developing the idea of and learning TypeFlow. So we're going to use all the nodes needed to complete the tutorial, and plus I'm going to explain the difference between a particle and a rigid or a dynamic object. So let's create a simple scene. We can get here a scene maybe, and let's get sphere. Okay, and put it here. Let's create TypeFlow. Open the TypeFlow editor. Let's put it aside there. Okay. As you can see here, we got some parameters to work with. Regarding the dynamic particle or the dynamic engine, excuse me, it is here the physics which affects the dynamic that you are going to work inside it. So this is related to dynamic, and this is the physical and bind solver. So this is for particles and this is for dynamic. If you need to increase the steps, it means the time it takes to calculate one frame. So the higher is the better, to give it more time to calculate the frame. So in order to take from 0 to 1 6 steps or sub steps, if you increase it to 12, it's going to do like 12, but the time of computing is going to increase, of course. So let's create that birth object, okay, and talk about it. So the birth object is going to convert any object to particle, okay, in order. So let's get birth object and pick this object. Now this object is being converted to a particle. If we zoom here, you can see there is a dot here representing the object being converted to particle. So we need to hide this object in order to see. So this is our object, like as I have explained before. So this is the way to display the particle here. We need to change it to geometry in order to see the full object. So is this the object? Of course, the answer is no. This is the particle and not the object. So we converted the object to particle so we can work with it, okay? Of course, if we try to move, we get nothing because we need the force. And let's keep an eye. Here, if we go to particle based solver, you can see there is not a lot of things we can do here. Okay, let's give it a force maybe. Let's go here, press tab and say force, or you can navigate it here, press F and drag it here. Let's give it a bit of gravity here, and we can see that it is moving as expected. We can add a collision and we pick this one. So now the particle is going to interact with the object, of course. As you can see here, the object is inside. We can fix this by going to maybe like distance of collision and try to increase this one up to here so we can get maybe something very close. Okay, maybe we need to go higher. Let's go, or we can change here absolute radius. We can change shape radius so we get the radius of the shape, so we get a more accurate representation of the shape. Okay, so always different things here you can navigate through and read. All are, so the bounce here when the ball just hitting. So if you increase the bounce, the bouncing, it's going to bounce like a light ball here. So let's keep it maybe to 10, and the friction is the same. If you're going to decrease the friction, it's going to, so we got no friction. It's impossible, we need at least some friction. Of course the friction is so strong. If we increase it up, we can see now it's going to stick. okay, with a variation of 15. Let's keep it maybe to 20. So we get less variation, and keep this one to 15. You can just test different results here, okay? Now we need to use something very important, a test using time. Let's bring it here. Let's say we want this thing to happen after maybe, let's keep it here. Let's say after 35. Let's keep test here. Let's delete this one. Test, let's say event frame greater than, let's say 35 or 34, variation, let's put it 0, and let's put this one here. You can see now the event starts working just after this frame, which is very handy to trigger any event you want based on time, okay? Remember, this one is very handy to do quick and dirty things. Let's connect our collision. We want the collision. When the collision occurs, let's change this one to geometry so we can see the shape, and let's change its color to maybe like red or something. So when the collision occurs, we get a change in color. So we come here, let's add a bit of friction, maybe to 15 or so, and let's see, boom, okay. Why? You can see the ball now is floating up. This is due to, we need to add the force here, but we won't do so. We need now to convert this object to rigid. Why? Because we need to fracture it. You can say, why we need to convert it to rigid in order to break it? The answer is simple, because the pieces need to interact, or need to interact with each other. We can do directly without converting this object. We keep it particle. Let's go here and add a Voronoi. This is how we fracture objects. Let's say Voronoi. Here you can set the number of fractures. Let's go like 20. Okay. So here when the collision occurs, if you press F4, you can see now the object is being fractured. Okay. Of course, it is flying up. We need to add gravity or any force. Let's add a gravity here. Okay. And let's see what is happening. Of course, nothing. We need to add a collision. Of course, we can just go collision and then pick the ground, or just shift and drag this one here. So, okay. We can see now. Let's play it. We can see the object is being fractured, but it's not real at all, because like the particles are not interacting with each other. Let's say this is particle, this is a particle, this is particle, are not being like the exterior volume is not being taken in consideration. So we need to convert it in rigid. In order, we can go to physics. You can read here, allows to convert particles into rigid. So we go here and let's add. Of course, now, if we play this one, you can see it is reacting the way that we were expecting. But keep in mind here, this force now, if we disable it, you just click, or let's remove it. Now we play. Wow, you can see, of course, let's remove even collision. What are you expecting? Of course, you are seeing a weird behavior here. It's not what you are expecting. You're expecting there is no force. So if we disable this one, of course, it's going to fly up. This is particle, of course. Now it is being a rigid. Because there is a rigid here, if you go to physics, as soon as you convert the particle to objects, it's going to be, I'd say, to be manipulated from this engine, which by default has a default gravity of -1 and has a default ground collider, which is the ground G. So even if we delete this one, of course, because the first event is not going to occur, okay? But you can see we have no collision even though the object is interacting. Let's go even further. Okay, let's go here. Because there is a default ground. If we disable default ground and default gravity, let's go, we can see the same behavior. Keep this in mind. When you are working with physics, this is the engine of physics. When you are working with particles, this is the solver of particles, okay? So in order to replace this default gravity, we can add here a force, of course, and we need also to add a ground. So even if you go here and add the force, let's shift and drag, put a force here. Let's see. Of course, now it's going to fall down because there is no collision or no default ground if you are working at 0, 0. So let's add a collision and pick. Of course, it is already. Let's go now. Of course, we got a problem with the collision here. We can try shape radius and we can see it's working. So we can increase this one like the other. It was like -1. So we get a strong gravity behavior, and you can see now. Of course, they are acting weirdly here. We maybe need to increase the steps, but it was okay working with the default gravity and the default collider. This is, I always start with it. It's more accurate. You can see now, it's good. Of course, we can add a lot of things here in order to manipulate further. So this is what I wanted to talk all about. Now